So this is our first question. The question is how many orbitals and electrons are situated with n equals to 4, right? If n equals to 4, then L will correspond to 0, 1, 2, and 3, right? So 0 will have 1 orbit, it will have 3 orbit, this will have 5 orbit, and 3 will have 7 orbitals. So overall counting will be 16. So each is having, like, S orbit is having 2 electrons, P is having 6, D is having 10, and F is having 14. So overall it gives 32. So option B will be right for this, like 16 orbitals and 32 electrons. So this is our next question. The question is an element with a mass 81 contains 30% more neutron as compared to proton. So find the symbol of the atom, right? So this is the solution what I have already mentioned. Like, let me explain the solution, right? So mass number of an element is 18, that is given. So combined it gives protons plus neutron, that is 81. So there is like, let consider the proton be x, then the number of neutron will be like the mass divided by 100. Like, this is the percentage what is given. Then we have to find out these two values, x and 1.3167x, right? So this collectively gives 81, right? So we have to find the value of x, that it gives 35. Then the symbol of an element would be boron 3581 according to this given solution. Like 35 and 81, the options are there. So this will correspond to option B. So option B is right. So this is the next question. The question is energy of a photon is given as this. Like, energy is given to us, and the wavelength of the photon that we have to find out, right? So for the wavelength, like, we have formula energy equals to hc by lambda. Then we have to find out the lambda. Then it will be hc by e. Then we'll substitute the values. Like for h, 6.6, 6.625 multiplied by 10 raised to minus 31. Sorry, 34 multiplied by 3 into 10 raised to 8 divided by the energy what is given, multiplied by 10 raised to minus 19, but it is joules, right? So by solving this we will get 656 nanometers. So option B will be right for this question. So the question is, Bohr's theory can also be applied to which of the atoms, right? So Bohr's theory is majorly applied to hydrogen atoms, right? Like, which atoms are having one electrons only. So this, like this, all three are valid for this hydrogen Bohr's theory. So all of these are right for this. So the question is, according to the Bohr's theory, the angular momentum of an electron in fifth orbit, right? So for this angular momentum, we are having formula, um, the orbit on which it is situated, h by pi. Sorry, by 2 pi. So this is the formula, right? So then we'll substitute the value of n, which is 5. So then 5h by 2 pi. So we can solve this by getting 2.5h by pi. So option B is right. So the question is, Bohr's model explain which of the following. Like, it is very straightforward question. Like, Bohr's atomic model always accepts that type of elements which are having one electron only. So option B will be right for this. The question is, a body of a mass 10 gram is moving with a velocity 100 meter per second. The wavelength associated with it. So as the required unit is in meter, so we have to convert everything in SI unit. So this gram we have to convert in kg. That will give us 0.01 kg, right? So we'll have that formula, like we have to find out the wavelength, right? So wavelength is equal to h by mv, right? So h is what, 6.625 multiplied by 10 to minus 34. Mass is given, that is 0.01 multiplied by, sorry, 0.1, it will be 0.1, then multiply by 100 meter per second. So by solving this, we'll get 6.626 multiplied by 10 to minus 24 as the answer. So option B is right for this question. So the question is, what will be the mass of a particle if uncertainty in its position? Sorry, the uncertainty in its position is delta x. What is given is 10 to minus 8 meters, right? And the velocity is given like delta v is given 5 by 26. Yeah, into 10 to minus 25 meter per second. So formula will be delta x m mass delta v equals to h by 4. So we'll substitute the value and find the mass. Then what we'll get is 0.01 kg. So option A is right. So the question is, which of the following is not correct statement regarding the energies of an object? So as we'll read all this, the lower the energy of an object, lower its energy. It is right. This is also right. The energy of s orbital is lower than p than yeah d. If the two orbitals have the same energy, then the orbital with higher value of n have lower energy. This is an incorrect statement. Like higher value of energy will have value of n will have high energy. So option D is right for this. So in this question, like all these configurations are given, and we have to find out the noble gas one. Like all the orbits should be fully complete. Like right. So here as we'll see, yeah, each orbit is complete, but it is not noble gas as the last electron enters in 5s2, and this is also like 5s2. 5 with this may be there, and this also, but this is half filled. This is completely filled. Noble gas represents this one, so option C is right.